plucked from the trash. Everyday objects are destroyed, then transformed by technology, reborn into modern marvels. Aluminum ladders melt down into parts for oil tankers. Wax cardboard boxes shred into fire logs. And skateboards roll into electric guitars. These are the things that are made by destruction. There's one leaning in every tool shed and loaded on every truck. The aluminum ladder is lightweight, strong, and rust-resistant. But eventually, these sturdy helpmates get grounded. Thanks to innovative technology and cost-effective techniques, broken-down ladders are stepping up to a new job. Every year, Ram Iron and Metal takes 20,000 tons of scrap aluminum onto their 12,000 square meter facility and turns it into a new product that really delivers. Aluminum ladders are recast as parts for an oil tanker. But to build them up, you've got to break them down first. A salvage worker tosses the ladders into a bin. After heading for the warehouse, he offloads the bin into an alligator shearer. Wielding 34,000 kilopascals, the alligator's powerful jaws chew up the ladders into shippable sizes. Then, a worker loads them out into a waiting truck. It's a short ride to the smelter, where the chunks of ladder will be cooked back into raw material. A forklift dumps the scrap into a furnace. The aluminum liquefies at 732 degrees Celsius, then flows into a 6-meter deep casting pit. Once it's cooled, a crane lifts out a 113 metric ton aluminum ingot. The 60-centimeter thick ingot rolls back and forth in the reversing mill. 2,200 metric tons of pressure flatten the ingot to just over 2 centimeters, stretching the slab into a 91-meter-long aluminum sheet. The aluminum is then shipped to manufacturers that will make many of the fittings for the tanker. To create the oil tanker, aluminum sheets are bent, rolled, and welded into the tank. The tank is harnessed to a truck bed, and vent hoses, gauges, and other systems are installed. Allmac Tank International makes liquid transportation tanks in all sizes, from the 1,900-liter to the massive 34,000-liter capacity. To create the tank itself, Allmac uses 100% virgin aluminum, free of recycled filler. The first step in creating an oil tanker is to join the aluminum sheets together. An overhead crane feeds 3 rectangular sheets into a seam welder. As the sheet travels through the seam welder, 2 computer-guided electrodes melt the edges of each sheet to produce the seam which joins them together. An operator marks the newly formed sheet with lines to indicate where it needs to be curved. A crane carries the sheet over to the rolling machine, where it will be bent to spec. The tech calibrates the roller to the exact angle of the curve. How much to bend depends on the final size of the tank. The roller makes 2 large bends in the sheet, defining the sides and the bottom of the tank. Workers guide the tank in progress to a spot on the floor where they'll continue its assembly. The operators use hammers and torches to tack weld the ends of the tank in place. Interior supports, called baffles, are installed inside the tank to give it added strength. Workers install 2 triangular baffles that will form a spill basin if there's any overflow while the tank is being filled from the top. After taping protective panels to the surface to protect the aluminum from scratches, workers park the tank between 2 positioner machines. The positioner acts like a giant rotisserie, providing easy access for final seam welding. Sparking a MIG welder, the workers melt the aluminum shell at 3,500 degrees Celsius, carving a molten channel into the aluminum along the seam line. They fill it with metal filler to smooth and seal the seam. This is painstaking work, and it must be done right. One leaky weld could mean a disastrous safety hazard. Once the welding is completed, the tank is tested to see how it holds up under pressure. An inspector drops a water hose into the hatch and fills the tank to its 34,000-liter capacity. He seals the tank, then pumps in 34 kilopascals of air pressure in an attempt to breach the welded seams. If the seams don't hold, the tank could burst and it will need to be re-welded. The tank passes the pressure test. The water is drained and the tank is ready for the next phase of construction. Installers trick out the tank with pumps, plumbing, and gauges, then secure it to the truck bed. Metal workers chop, melt, and press discarded ladders into 90-meter sheets of pristine aluminum, which they shape and weld into a 34,000-liter tank. Eastway Tank Pump and Meter Limited turns a hollow aluminum tank into a fully functioning tanker truck. The tank has been transported to Eastway, where it's now positioned above a truck bed in the assembly bay. An overhead crane lowers the tank onto the truck's frame. An installer uses a pneumatic wrench to lock it in place. Then, technicians install the tanker's pumps, gauges, and other systems that will help it safely transport and deliver gas or diesel fuel. An inspector tests the entire pump and monitoring system to make sure every component is functioning perfectly. A worker applies a few finishing touches, and this rig is ready for the long haul. Aluminum ladders on their last legs have been rescued, recycled, and reformed into parts for oil tankers. And that's a step in the right direction. Waxed cardboard boxes are a popular way to get fruit and vegetables to market. The wax keeps the container water resistant and preserves the produce. Unfortunately, it also preserves the boxes. 1.5 million waxed cardboard boxes are produced every day in the US. All those boxes eventually end up in landfill. That's a mountain of boxes, 150 times the height of Everest. Thanks to an innovative manufacturing process, waxed cardboard boxes are being transformed into a hot new product. At their 6,500 square meter plant in Gridley, California, Clean Flame rescues 10 million cardboard boxes from the landfill, saving 200,000 trees every year. They can also save you some money on your heating bill. Waxed cardboard boxes reform into fire logs. To pull off this transformation, workers need to shred, dry, and extrude the boxes. The first step in destruction is sorting. A forklift ferries bales of flattened boxes to the sorting area. Produce boxes are made up of a corrugated sheet of paper sandwiched between two sheets of cardboard. The cardboard is coated with food-grade wax that helps the finished fire log burn slowly like a candle. Workers pick through the boxes, keeping the ones coated with wax and recycling the others. They also blend the wetter boxes with dry boxes to ensure the production line runs smoothly. The waxed boxes travel up the belt and drop onto a 4-shaft shredder. 4 sets of cutters repeatedly grab and shred the boxes, cutting them down into 5 centimeter by 5 centimeter cardboard chips. Once they're small enough, the chips fall through a grate onto a conveyor belt. Workers inspect the shred, pulling out bits of plastic and any non-waxed cardboard. The next step in the destruction process is heating. The 5 centimeter chips ride along a conveyor and land in a hopper, which feeds a dryer the size of 2 school buses. Inside the massive rotating drum, the cardboard is tumble-dried and heated. Wasted cardboard boxes have been reduced to 5 centimeter chips. Now they're ready to work under pressure. The chips will be packed into an extruder and reformed into clean-burning fire logs. The recyclers at Clean Flame sort, shred, and dry waxed, corrugated cardboard boxes, chopping them into 5 centimeter chips. Time for their transformation. The first step in the creation process is forming. The cardboard chips drop into an extruder. A spinning auger squeezes the shredded pieces together. The wax helps bind the compressed chips into a single log. After about a minute, a rectangular log emerges from the extruder and into the blade of a guillotine. The sharp edge slices the log into 60 centimeter chunks. An inspector weighs the individual logs. A 2-kilogram log will burn for about 3 hours. If the log is underweight, it goes back into the extruder to bulk up and get reprocessed. Once a log passes inspection, it heads down the line for packaging. Tightly wrapped in a paper sheath that's chemical-free and made for quick lighting. A shipper packs them into boxes and stacks them onto skids. Clean Flame produces up to 10,000 logs per shift. Visionary thinking and smart technology sparked a good idea. Cardboard boxes that might have ended up in landfill have become slow-burning logs. Step aboard a plank of wood with a set of wheels, and you're rolling with over 13.5 million sidewalk surfers. Most skaters can pull off these gnarly stunts without broken bones, but there are plenty of broken boards. Because of their unique construction, the wood can't be recycled. But now there's a way to turn sick tricks into cool licks. The craftsmen at Prisma in San Francisco have found a way to shred a skateboard in a sensational new way. Skateboards are transposed into one-of-a-kind electric guitars. Inside their home studio, craftsmen slice, strip, and layer skateboard decks into handmade instruments that are making a lot of noise in the music community. Every custom axe is made from 10 hard rock maple decks fused together to make a unique guitar body. The first step is stripping down the boards. The craftsman chooses decks that are different in color and grain, so when they're stacked together, they create a distinctive layered look. The guitar maker unscrews the wheels and suspension, or trucks, from the board. The hardware is set aside for reuse. Using a razor, he pries the grip tape from the top of the deck. Then he peels the tape away from the wooden surface. Decks come in all colors, so the 10 boards that build a single body create a cool palette on the guitar's surface. Step 2 is sanding. The craftsman uses an angle grinder to smooth away flecks of tape and surface flaws. He runs the deck under a bandsaw to slice off the nose and tail, cutting them down to uniform 45 centimeter by 19 centimeter rectangles. These X skateboards are ready for a rebuild. The boards will be glued, stacked, and carved until 10 discarded skateboard decks can go to 11. Prisma guitar makers take broken down skateboards, pull off the grip tape, strip down the hardware, and cut them up into boards. The multicolored maple is ready for recreation. The guitar maker picks 4 boards to layer into the guitar body. He applies a generous coat of glue on each board. Then, he spreads the surface for maximum coverage. The craftsman piles the tacky boards into a stack, then transfers them to a press. He cranks the press down, fusing the boards together into a single laminate. After 8 hours, the glue is dry. The craftsman pulls the laminate stack from the press. He feeds it through a planer that shaves away any bumps and blemishes, so the laminate is perfectly smooth and symmetrical. A joiner squares off and cuts down the sides, so they'll make a precise join with the other piece. The craftsman spreads glue along the sides of 2 laminate board stacks. He presses them together, then clamps them tight. After about a day, the guitar maker loosens the clamps. The glue has bonded the 2 stacks into a single solid block. He sands the surface to remove excess dried glue. The guitar body is ready to take shape. The craftsman traces a classic electric guitar template on the laminate surface. Then, he uses a bandsaw to cut along the trace lines. He follows up with a router to refine the lines and round off the multicolored edges. A plunge router digs into the body, hollowing out the cavities that will house the electronics, and a notch to fit the neck. A drill press cuts holes to anchor the guitar's bridge. The guitar maker uses a file to sculpt the cutaways and contours for added playability and style. He gives the instrument a final sanding to bring out the grain before the maple body is sealed. Finally, a coat of clear lacquer gives the instrument a protective finish and a high shine that enhances the one-of-a-kind color scheme. Time to make this guitar an electric guitar. Guitar pickups are magnets, wrapped with hair-thin copper coil. When the metal strings vibrate, they disturb the magnetic field and turn it into an electric current that's the same pitch as the vibrating string. This electronic signal travels to an amplifier, which converts it back into sound. The guitar maker solders the wiring to the pickups and connects them to the input jack and tone and volume controls. He screws the neck into place and winds the strings onto the tuning pegs. A guitar is born. All that's left to do is plug and play. When skateboards hit the street too hard, they can be turned into a finely tuned instrument. Sounds like an awesome idea.